Alright folks, welcome back after the Easter break. I hope you had a good break. Just wanted to run through some of these laws of indices. We're doing 5 to 9 today, and these are all on page 21 of your log tables, so you don't have to learn them off or anything along those lines. The thing that I need to make sure that you're cleared about though is how they're written is very confusing to some people with the letters in them. We've got A's, B's, P's, Q's in there, and people get mixed up with that a lot of the time, especially if you're drawing it like me, and an A and a Q can be easily mixed up. The thing that I would suggest doing is just putting in some numbers. Just put in some numbers to make sure that you're clear on what's happening in each of the laws, and then you shouldn't go far wrong, especially numbers that we know we can work with easily. So when we're talking about squared numbers, we usually talk about 4, 9, 16, 25. If you use those and their counterparts, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and square root of 25 is 5. If you use a grouping or some of those numbers, then you should be alright. So law 1, as you can see, I've drawn a box around already. I'm just going to get into the idea of a root. The idea of a squared root, cubed root, any kind of root is this shape that we've talked about. And we generally use a square root, and most of the time we don't put the number in, but when we're talking about square root, it actually has the 2 there, because I'm talking about a squared number. So like I've shown you here, the square root of 4 is 2, because 2 squared gives you 4. So the squared root of 4 is 2. Okay, so if I was to draw that there, square root of 4 is 2, as you guys know. Alright, so when we're talking about a root, we've got all of those things. The thing that we don't have is we can change that number, and that's what happens in rule 5 here. So at rule 5 we can take any number that we want, and if it's powered to with a fraction with a 1 on top, so you can see the example that I've got there, 25 to the power of a half, or 8 to the power of a third. We use the denominator of the fraction as the root. So in this one, it's squared root, because I'm talking about 2, and 2 is the number that we use to square something. So it's the squared root of 25, or the square root of 25 giving you 5. In this one, it's a cubed root, because it's 3 is the denominator. So I'm looking for the cubed root of 8. What number do I cube to give me 8? And in this case, it's 2. So we can put any number that we want to there. We can put 5, 10, 50, 82. Doesn't matter what the number is. We can put any number that we want to in this space. And all it does is just changes what we're actually looking for. So if there's no number there, as a rule, we're looking for the square root. But if we're looking for the cubed root, we put a 3 in. If we're looking for the 4th root, we'd put a 4 in, and so on and so on. Nice and straightforward. So that's all that's happening there. So I can say something, a number, as you said, 25 to the power of a half is the same as the square root of 25. Or 8 to the power of a third is the cubed root of 8. Rule 6. Very similar to what's happening in rule 5, except instead of a 1 as the numerator in the fraction, I've got a P. And again, that's just representing a letter. P can be any number that we want it to be. And you can see in the example here, I've got 16 to the power of 3 over 4. So, 16 to the power of 3 over 4, if we go based on what's happening in rule 5, I know I'm looking for the 4th root of 16. That is based around my denominator and my base number. Now, because the 3 is on top, the 3 is the numerator, I have to incorporate that as well. And usually I generally go and put it's going to be cubed. And that's all there is to it. So I can find the 4th root of 16. What number do I multiply by itself 4 times to give me 16? I've done it there. 2 times 2 times 2 times 2 gives me 16. So the 4th root of 16 is 2. So all I'm left with then is 2 cubed. As the cubed is carried over, all I've done is change that to that. And 2 cubed is 8. Nice and simple. Root 7. Just let me clear these, sorry. Rule 7 then. We've got negative power. Now all that's happening here is that we're moving a power above and below a fraction line, alternative to doing whatever else that we're talking about. So the way that you guys have used this is from law 2. Usually this is the nice and simple part. If I've got a number like that, I've got 9 to the power of 3 divided by 9 to the power of 5. I know that I've got 3 of them. What I usually do is I just subtract those. When I've got a division, I just subtract them. That becomes 9 to the power of minus 2. Nice and simple. If I do it a different way, again, I can have my 3 9s, 9 by 9 by 9, all over 5 of them. 9 by 9 by 9 by 9 by 9. And I can cancel them out. I cancel out the 3 above and 3 below. I'm left with 1 on top because they count in to get 1. And I've got 9 squared. I can then say that those two things that I found, that and that, are the same thing. So I can say 1 over 9 squared is the same as 9 to the power of minus 2. All that's happening, if you really want to think about it this way, I've just brought that number above the line. And because I brought it up, I've changed its sign. Very similar to what you would do when you're bringing something from one side to the equals to the other. So that's all that's going on there in Rule 7. Rule 8, very, very similar to anything that you guys have done before with powers. You can imagine if I've got 3 to the power of 4, I know that this is the number I multiply. This is the number of times that I do it. 3 times 3 times 3 times 3. Because that's my base number. And that's how many times I am multiplying. Exact same thing here, it's just that we've got 2 parts in it. That I've got AB to the power of P, which gives me A to the power of P and B to the power of P. And I just multiply those together. It's exactly the same. You can see it here in 2 different ways that I've done it with 3B cubed. Lovely way of doing it. You can see I've got 3 cubed by B cubed. Each part is to the power of the number on the outside of the bracket. Or, alternatively, you can just do it like that. Because that's how many times I have to multiply 3b by itself. 3 times. Nice and straightforward, I think, that one. And then finally, 8 and 9 are pretty much the same. 9 is just dealing with a fraction instead of 2 numbers beside each other. It's done in exactly the same process. I multiply the fraction by itself, the number of times that I need to. You can see it's 4 over 5 to the power of 3. So I've got to do 4 over 5 by 4 over 5 by 4 over 5. Alternatively, you can take each part and it could be 4 cubed over 5 cubed. And that will give you 4 by 4 by 4 over 5 by 5 by 5. So no different there. Okay? So that's rules 5 to 9. I want you to use these, hopefully, to be able to attempt some of the problems that I'm going to give you now. So use them as your base, your foundation for all of this. We need to look at these carefully, see how they work. And as I said, if we're not too hot and we're not too comfortable looking at the letters, just pop in some numbers. Look at the worked examples that I've given you. See how it changes the values that we're talking about. Try a couple, pop in different numbers yourself that you know that are going to work, as I've mentioned over here, and see the relationship that's involved using these rules, using your calculator, and how they all tie in together. Thank you.